One.
Hello everyone, I am back this time with Womble and our guest for this hour, Katie Steckles.
Hello.
Let's start with the obvious. Who are you and all of that stuff?
Okay, well, I'm a mathematician, which I guess is the most obvious way to describe myself. I guess the things that people may have heard of me from is that I've done a few videos for the Numberphile YouTube channel, which is a maths-based YouTube channel where they talk about different types of maths and all the interesting stuff around it. And I also just generally do bits of other things at science festivals. So anyone based in the UK may have seen me at a science festival, but yeah, maybe not everyone.
Okay, so for this hour, we were told that you had some math puzzles. Yeah,
I do. I thought I'd bring some along. So basically, to give you a sense of what I do generally for a living, I'm a mathematician, but I tend to do mostly popularisation of maths. So what in the UK is called outreach or science communication, and I guess it happens everywhere. And I do kind of maths talks in schools, I do things at science festivals, and I do all kinds of stuff. And one of the things that I'm really into is recreational maths, which I guess is to do with not necessarily maths that's going to be used to do things in the real world or as part of maths research, although I have done maths research and it is fantastic. But recreational maths has gone from being a hobby of mine to being essentially part of my job, which is great. So I've got a whole selection of puzzles and things for people to have a go at. So, I mean, do you want one now? Should I just throw one out there to start with? Okay, so let's start with this one. Okay, so there's a book which has numbers on the pages, and the numbers start from 1 and count upwards, as is conventional with a book. And the total number of digits used to do all of those numbers is 183. And the question is, how many pages are in the book?
Okay, I'm giving that to the chat room. That's an interesting one.
I think I've got an answer.
Yeah, I can probably come up with one. Let's see.
I did it in my head though, Marty.
Yeah, they were numbered as usual, you said.
Yep.
Yeah.
Yeah, it's kind of a nice little one. I use this one a lot when I go into schools, and kids can usually work it out in about a minute. But it depends. It's one of those ones where it's quite easy to get it wrong, because you're like, how many pages are there between page 10 and page 90, or between page 10 and page 100? Is it 90 pages, or is it 91 pages, or is it 89 pages?
Yeah.
Sorry, just getting a few requests from the chat room if you could repeat it. Well,
yeah, do you want me to type it in, or?
Just explain it again, that should be...
Yeah, okay, so there's a book, and the pages of the book are numbered starting from 1, and the total number of digits used in numbering all of those pages is 183. And how many pages are there in the book?
Anyone? By a page, do you mean a proper? Do you mean a piece of paper or a side of a paper? I'm assuming it's.
Yeah, a page is a side.
Yeah. 92,
Oh, we've got two answers.
95.
Okay, the chat room is stumped.
96.
Well, I think it's 92. We've got an 183 and a 27. I think some people are just throwing numbers.
Yeah.
Yeah, we've got a range of answers. I can tell you the correct answer is on there. So it's amongst those.
Microblogism has obviously gone for the meaning of life, the universe, and everything. It's 42.
Another one for 95, it appears. I'm not even trying.
Okay, so
96,
what do you reckon? Should I give you a bit longer to think about it, or I don't know?
No, let's just.
Okay,
Womble, Womble,
yeah.
what answer did you come up with?
Oh, I already said it. 92 was
92.
my answer. What about you, Marty?
I haven't tried. I've been paying attention to the chat.
Are you having a geologist beat you at maths?
Evidently, because I'm not trying.
That is one way to get beaten. Okay, well, yeah, the correct answer is on there. Someone has got it in the chat.
Oh, tension's mounting.
Okay, any other answers just before I give it away? Anyone working on it that wants me to hang on a second so they can put their answer up?
I could do a countdown, time countdown, just to...
Yeah, that'll work.
The noise, it goes. That's my
Okay, that's
countdown thing.
Is that time up?
I think so, yeah.
Okay, so the actual answer is 96. And it's on that. I say it's one of those ones where it's really easy to be out by 1 or 2 either way, just because it's kind of the number of pages. But basically, yes. So there's pages 1 to 9 which use 1 digit each. So that's 9 of the digits. And then if you take that away from 183, you get 174. Yeah, 174. Is that right?
Yeah.
Oh, I've got a computer in front of me.
That's right.
I'm going to check my answer. Yeah, so 174, and if you divide that by 2, because that's the number of, it's going to be all 2-digit numbers, that gives you another 87, and 87 plus 9 is 96. Yes, so Dave wins. I don't know what you win, Dave.
The honor of making a donation.
Yes, and being extra brilliant for it.
Yeah.
Yes, it's quite a nice...
We are, after all, trying to raise money for charity here still. And just because we've raised over $3,000 so far, that doesn't mean we're going to stop. So keep the donations coming. And yes, vote Jordan when you make a donation.
Oh, this for the Idiot of the Year award.
Yes. $1 is 1 vote. Remember, we are doing the corrupt democracy version here.
Good.
So the more you donate, the more votes you're putting in towards Jordan.
Yeah. Although it wouldn't be that bad if Ken Ham wins either, but I still think it's better to give money so that Jordan wins. And the Engineers Without Borders get more money.
Yep.
Cool. So is this 24-hour podcast? Is it people being awake for the whole 24 hours?
Some seem like they're being up all the time. I took a few hours off.
I had to have a sleep and unfortunately woke up with a really horrendous headache.
Oh.
But it's all gone now.
Good. I admire your commitment because I think it's fantastic to raise money like this. I know some people have done really daft things to raise money for charity, and this is a really great one because I listened to a bit of the previous one and it sounds like there's some really fantastic conversations been happening, so it's good.
Yeah, and unfortunately poor Zulu is the only one that cannot have a break at all during the 24 hours because he is doing all of the technical gubbins.
Oh no.
Yeah.
Yeah, there's always one guy who has to do that, isn't there?
Yeah. I unfortunately have the tech skills of, an average hamster. I can do stuff, but I also have a reputation for killing computers in interesting ways. So I'm not allowed to go anywhere near tech. So have we got any questions from chat? Maths questions? Do you have any bits of homework you need help with if you're at homework age?
Yeah, I'm happy to answer maths questions, not necessarily to do people's homework for them. If you do ask me a question that's your homework, I will give you a hint, but maybe not answer it. I don't know.
How have you found the impact of doing going into schools and doing the maths work? Is it something that's encouraging youngsters to get into maths?
I think so. So the kind of stuff that I do is what's called enrichment, which means that I don't necessarily go in and talk about the maths that they're studying for their exams or for school, but that they they are given stuff that they wouldn't normally get to see. So things that aren't on the curriculum, things that you don't even necessarily get to until you do maths at a higher level, like at university. And what it means is that they get to see kind of where you can go with it, kind of almost that, the maths that you learn at school is quite functional and it's really useful stuff, but it's stuff that you need to be able to do in order to get onto bits of other maths and to do other things. So the stuff that I'm showing them is stuff that's, I'm not going to say it's more exciting, because I know that maths teachers do work really hard to make maths lessons interesting and, to give people, the best possible start. But it's stuff that, the kind of really cool stuff that you can use that stuff for. So I'm hoping that what it does is gives them an impression of how maths can be useful, and also just why it's fun. If they see something and they think, oh, I've just done an hour of maths and it wasn't completely tedious and it wasn't, horrible and difficult, then, maybe that gives them a bit more confidence when they go back to a maths lesson. And it's quite cool because sometimes I'll do things like origami stuff. So there's loads of really nice paper folding things you can do that build kind of mathematical objects. And if you give that to a class of kids, sometimes the kids that think they're good at maths or that do well in their exams will find it more difficult, and the kids that don't tend to do as well will get on with it, and they'll be showing the other kids how to do it, and that gives them such a real confidence boost that that when they go back to maths lessons, it's all there. It's great.
Cool. We've had a few questions come in from chat. I think if me and Marty ask them alternatively, I'll go with one that was posed without question marks, so Zulu didn't pick it up. How many mathematicians does it take to screw in a light bulb?
Ooh, that's a good question. There's probably a really funny answer to that. Yeah, I. Yeah. There's probably plenty of funny numbers you could say in response to that. What's a good one? I don't know. Do you want
to get the next question, Marty?
I can do that. Do you know how to use a slide rule?
This is a good question, because I don't, but I really would like to. And slide rules are really cool. If anyone doesn't know what a slide rule is, basically this is what we used to use before we invented the calculator. And it's a way of calculating things like logarithms and things like, doing kind of quite difficult computations, but you basically have sort of sets of numbers and you line them up against each other and you can look up across, and it basically lets you do these calculations more easily. And before we had basically electronic calculators, anyone who did calculations, even in things like in industry, for engineering stuff, they would use a slide rule because it was basically the quickest way to do these computations, short of going and finding a supercomputer somewhere and getting that to do it. I know I was reading a book recently. Alex Bellos has just written a book. It's his second book, and I think it's in the UK. It's called Through the Looking Glass. It's some kind of Alice in Wonderland pun, and in America it's called something else. I really should have looked that up, to be honest. But anyway, Alex Bellos' second book, and I recommend it. And there's a whole chapter about slide rules and how people used to use them. And he goes and visits a guy who's got like a huge collection of slide rules of all different types. And it's really cool because there's just this relic of maths that no one even uses anymore. But they're all these beautiful objects. And some of them are really nice, kind of well-made, handcrafted things. Some of them are just cardboard. But, they used to be a huge thing. But I never learned how to use one. And I should. Like, I read it and I was like, oh, that makes a lot of sense. That sounds like a really useful thing if you don't have a calculator. But I can't use one. So...
Okay, so we had a question here on trigonometry. Can you explain how you find an angle from the inverse trigonometry function without using a calculator? Wow,
that is a good question. I guess a calculator is the easiest one to do it. So there are ways to calculate the values. So things like sine and cos, which are trigonometric functions, you use these to work out for instance, if you have a triangle, you can use them to work out the relationship between the angles of the triangle and the sides of the triangle. And they come up in all sorts of other things as well. So if you have, for instance, a wave that you study, if you're looking at kind of sound or whatever, the wave will be made up of sine and cosine waves. There'll be kind of combinations of different sine waves added together. So they come up in loads of different areas of maths. But the actual curve itself, you can plot it on a piece of paper. So I can never remember which way around these are, but sine and cosine, one of them starts at 1 and one of them starts at 0, and they kind of do this wave. So if you plotted them both on the same thing, they sort of cross over each other all the way along because they're out by half a phase. And you know, you may have seen this kind of curve, just a sine curve. So if you needed to find an angle, you could, in theory, plot a sine curve and then look it up on the graph. That would be one way. I don't know. But without a calculator, I would just use a calculator, to be honest.
A similar question is how all these logarithms that people figured out, and this goes into how the first slide rule was made. How the hell do you figure out what the natural logarithms?
I guess you. I mean,
if you don't have a table to check or a calculator, do you?
Yeah. You can approximate. You can do trial and error until you get close enough. And I think I'm trying to remember how they calculated the first log tables. It was kind of quite a laborious process, and this is why they produced these books of log tables. This was an alternative to using a slide rule, or maybe something you use alongside a slide rule. That you have a book that's just literally got a load of tables that you look up the values of things. And yeah, before they had calculators, this was how a lot of it was done. Once people had worked out these values in the log table, that was just the book, and you could buy it. It was like a thing that you just put on the table and open up and use. Yeah.
Okay, we had another question. That's from Dave. Can you prove the Goldbach conjecture real quick?
Can I prove the Goldbach conjecture real quick? I wish I could, because that is a pretty serious result in maths. So there's a whole bunch of things that mathematicians haven't got the answers to yet, and the Goldbach conjecture is one of them. The reason it's called a conjecture is because it's something we conjecture may be true. That's not really a word that people use normally, but we think it's true, and it's been suggested that it's true, but no one's managed to prove it yet. And the Goldbach conjecture says that every even number can be written as a sum of two prime numbers, which seems like a fairly straightforward thing. So if you think of an even number, I guess above a certain value, so I guess 4 is 2 plus 2, 6 is 3 plus 3, and then kind of any even number above that, you can think of a pair of prime numbers. So 52, you could write as 47 and 5. There's loads of different ways you can do each one. But, checking that all of the even numbers can be written as a sum of two primes isn't going to get you anywhere, because there are infinitely many of them and you're never going to check them all. So what we need is some kind of proof that in general this is true. And the Goldbach conjecture is something that's been around for ages. People haven't been able to prove it, partly because prime numbers are still a little bit of a mystery to us. Like they're something that we use a lot and that are really kind of well studied, but there are things about prime numbers that we can't quite kind of figure out yet. And one of them is, so prime numbers are basically numbers for multiplying. They're factors of things. Everything could be written as a product of prime numbers. So when you go to adding prime numbers together, that's when things get a little bit weird, and we're not really kind of as up on that. So maybe the Goldbach conjecture is difficult for that reason. Although we have, and this was in the last couple of years, proved a thing called the weak Goldbach conjecture, which is a version of the Goldbach conjecture that's not as strong, hence the name. And what that says is that every odd number can be written as a sum of 3 primes above like a certain number, maybe 7, or from 7 upwards. Any odd number can be written as a sum of 3 primes, and that has been proved. And that doesn't necessarily give you the Goldbach conjecture, but it's sort of a step on the way. So we're getting there. But I can't prove the Goldbach conjecture. If I could, I wouldn't be here now. I'd be off proving the Goldbach conjecture and getting all of the acclaim, and they'd probably rename it the Steckles theorem or something. I don't know.
So here's another question. Can you find X?
Can I find X? There it is. Yeah. It's there on the screen.
That's the answer I had in mind as well.
Yeah.
Okay, we still haven't received a single donation for this hour. That's unacceptable, people. Come on.
Come on, donate some money. It doesn't have to be a lot. We're not asking you to donate your life savings. Just $5 or £1 or whatever it is that you can spare would be amazing to receive.
Oh, there's an interesting question. What's your favorite number?
Oh, that is an interesting question. This is something that Brady, who does the Numberphile videos, asked me because I was filming some videos with him, the ones that I'm in. And when we'd finished filming, we said, well, you know what, we can do another quick video before we finished. What's your favourite number? and I had to kind of come up with a favourite really quick, because it's not something everyone's necessarily thought about, and it's kind of interesting. So Alex Bellos, the guy that's written the book that I can't remember the name of, he did a survey online where he got everyone to put in their favourite number and say kind of, why is this your favourite number? What do you like about it? And he really analysed the results, and there's some really interesting stuff there about kind of the psychology of people and how they interact with numbers. So when I was asked by Brady, what I said was, and I think this is probably true, that my favourite number is 27, because 27 is a cube, and it's like, so 3 is quite a good number. 3 is nice. I like 3. And 27 is 3 to the power of 3. So it's like 3-ish. It's more 3 than 3. I don't know. But we also, when we were doing the video...
3 times 3 and 2 plus 7...
Yeah, 2 plus 7 is 9, because it's a multiple of 9, so you end up... Yeah, there's lots of nice kind of 3-ishnesses about it. And yeah, 3 seems to be a fairly popular number, but having 3 as your favourite number is kind of boring. So... that was sort of my reason for having 27, and he said, we need a better reason than that for the video, because it's kind of a bit vague. So we looked up... Thanks, good joke, Dave, thanks. So I'll come back to that in a second. We looked up kind of facts about 27, and we found that 27 is a number which is at the 27th decimal place in pi. So there's this property of certain numbers that exist in the digits of pi expansion at their own value. So if you go to the 27th decimal place, 27 starts there, which is quite nice. And I imagine there's quite a few numbers that do this, but there's not many. It's not every number. So 27 has that about it, which we thought was quite nice. So we did that.
Number of numbers that do that, shouldn't there?
I guess, yeah. In theory, pi is normal and therefore has every possible combination in it. So if it goes on long enough, you'll find everything there. But 27 is a smallish number that has that property, which is good. So the joke that Dave's just put in the chat is 27 is nice, but 28 is perfect, which is nice because 28 is what's called a perfect number. And that's a number whose factors sum to the number themselves. So 28 is divisible by 1, 2, 4, 7, and 14. And if you add those up, you get 28. So it's a perfect number. It's nice.
Mm-hmm. And my favourite number is 42.
That is a good number as well.
That's too predictable.
I'm a geek. What do you expect?
True.
Yeah, and well, it's quite often when I go into schools, they do a trick where I have to get the kids to pick a 2-digit number. And always someone picks 42. And there's always some kid who picks 69. I don't know why. They seem to really like that number.
They're school children?
Yeah, that'd be it.
Just think pub mentality.
Yeah, so I see we basically sparked off a whole debate about which numbers are the best in the chat. This is what happens when you mention what's your favourite number, because everyone's like, no, that number's rubbish, my number's the best. 36 is quite nice.
Depends whether or not we actually get to spark any riots with something like this. That would be a little bit of an extreme maths-loving session thing.
Do you happen to have any other puzzles?
I do, yeah. Let's do another puzzle, that'd be good. Okay, so... Oh, that's nice. So I was looking at the list of birthdays in the newspaper last week, and I noticed that Michael Phelps, the swimmer, has just turned 29. And the puzzle is, how long will it be until Michael Phelps is 1 billion seconds old? So how many years is 1 billion seconds, and how long is it until Michael Phelps hits 1 billion seconds? So that's one to work on, I guess.
Yeah.
We can carry on chatting.
Yeah.
That's one that's hard to do in your head.
It's quite nice because 1 billion seconds, it turns out, is achievable. Basically, everyone will get to 1 billion seconds, so it's quite a nice fact. Yeah.
Have you ever had to deal with people that really just go on and on about how wrong maths is?
I guess I don't think it's common for people to say that maths is wrong, but that they don't like it is the most common
what I meant.
thing. But I mean, pretty much everyone agrees that maths is correct, right? This is the thing about maths.
I've come across people who say
Really?
it's wrong and they can disprove the whole thing, and they point to things like how 0.9999999 equals 1, and therefore the whole thing falls apart. And that is a problem. Don't get the definitions of numbers.
Yeah, I think the thing about maths is it's a language. Like
Yeah.
as a subject, I think it fits in more with languages than it does with arts or sciences. I mean, it is science and it connects to a lot of science, but you know, it's basically a language. You're essentially learning how to look at the universe and interpret it and convert it into numbers and how to kind of discuss things in that language. And it's really cool for that reason. And I think if you don't kind of get it, it is easy to become kind of jaded against it. I think in terms of people who hate maths, I think basically everyone I've ever met has given me their opinion of maths. It's one of those things that really polarizes people. And kind of if I get in a cab somewhere and someone says, you know, what do you do? Or if I'm at a party and someone asks me what I do, I'm almost sort of reluctant to say, oh, I'm a mathematician, just because I know that they'll go, oh, I hated maths at school. Mm-hmm. And you think, right, well, you know, that's a really unhelpful thing to say, because that's just shut down this conversation. Like, I now have to either defend maths or sympathise with you, which makes me look like an idiot. And, you know, if you're at a party and someone says that, you're like, all right, well, what do you do? Because I hate that, you know. It almost seems like a rude thing to say to someone. But it is quite a common thing, and it's partly because maths is difficult. I'm not going to argue it's not. But it's one of those things that if you put the effort in, you get so much out of it. Mm-hmm. And I think people who've had either bad maths teachers, which I hate to say it, but does happen quite a lot, people who, you know, maybe didn't quite get it or didn't get taught it in quite the right way. But the nice thing about maths is there's so many ways to approach any given thing. So if you have a problem, there's probably 2 or 3 or 4 different ways to approach that as a question. And if you get a good maths teacher is someone who will see that you're not getting it and show you a different way around to the same point. Whereas some maths teachers maybe have a way that they teach something and they'll always teach it that way, and it doesn't work for everyone. Not everyone will get it. And if you show people these alternate ways around to things, sometimes that can be enough to kind of unlock it for them. So I don't know. But a lot of people...
for the record, I'll let you guess what I do for a living.
Are you a mathematician?
Math teacher.
Oh, excellent. Yeah. Well, this is the thing, and it's about showing people what's out there, because a lot of the problems that maths teachers have are the fact that they literally have to get through all this stuff just because this is stuff people need to know. And I'm not going to say it's not useful stuff, but it can be quite kind of laborious to get through all of this material.
Absolutely. Yes.
We've got a comment there that says, I get why maths is important, but I find it tedious. And I'm not going to lie, some mathematicians working at research level, when they're doing a bit of maths, find it tedious, because there are aspects of it that are kind of just, you have to work this thing out. But when you get there, when you get a bit of inspiration, or when you find a really useful application of something, or you're trying to solve something, you're trying to work something out, and you find the maths that works and makes it happen, it's amazing. It's, you know, it's such a beautiful thing sometimes. So that's why people still do it. And it's just kind of communicating that to kids. And if you can work with a group of kids and say, you know, give them a problem that they can work out the answer to themselves, and they get that little buzz of kind of problem solving and finding the answer to something and getting it to work, that kind of helps them, I think, in enjoying it a little bit. But yeah, it can be tedious.
Yeah, and it's this simple. It's not for everyone. That's another thing that I notice all the time, that, you know, some people are just not going to be interested in it no matter what. People are just different. Some people are more, it's like they have a natural affinity for one type of stuff, you know, and others another.
Yeah, and I mean, definitely it takes all kinds of people. Like, you know, if there weren't kind of people in the world that were amazing at art or music or whatever, we wouldn't have any of that stuff, and that would be rubbish. Exactly. But I think it's difficult, because there's like an age when you're a kid. I think someone told me they've done studies, and I think it's about 9, that you basically decide whether you're into science or not. And at that age, kids make their mind up as to whether they're going to be into science or whether they're going to not be into science. And it's really horrible, because you shouldn't have to make that decision. You know, it's perfectly possible for someone to be into both, you know, and to have a really broad kind of thing. Because I'm a mathematician, but I feel like maths is quite a creative thing. And I'm also a little bit creative, and I like to make stuff and do things and, you know, mess around with ideas and stuff. And I think it's a shame that people are basically forced to choose whether to be a logical person or a creative person, because they both kind of work together. Yeah.
Unfortunately, it's often hard, given the level of math that I teach, which is high school, it's very hard to see the creative aspects of that. When I was in high school myself, I didn't see it. I just saw it as solving problems. Okay, I like that, so, but I get why everyone doesn't. But I didn't see anything creative about it. I did start seeing that in college, though.
Yeah, and I think it's... Sorry, come on.
I was going to say, I know for myself, when I was at school, that the subject areas that I had my greatest strengths in were maths and science. And one of the things I used to love about doing maths and the maths and science in school was the fact that I was always looking for the patterns and the tricks and the number relationships. That's the bit I kind of really got hooked into when I was doing maths. And I saw that.
Wisdom Vendor points out to me, Marty, try showing real-world applications. That's not the issue. I do that all the time. That's like the simplest thing you can possibly do. Try to show what this is for. Unfortunately, that doesn't really help the people who simply go, well, I'm never going to solve a problem like that anyway. And you'd be surprised, well, maybe you won't be surprised. It's just, consider a high school kid who isn't interested in math saying, well, with this you can solve problems like this. Then he's going to go, well, if I have a problem like this, I'm going to ask someone else.
Yeah, a lot of teachers in any subject, because I know quite a few teachers, they do always talk about how they are putting what they're teaching in real-world applications. So it's not something that isn't being done in schools.
Yeah, I think the thing about maths for me is you can, a lot of kids will say, why are we studying this? What do I need this for? And I think part of it isn't just that you're actually going to do that thing again. Like, you'll learn a technique, you'll learn a way of doing something. You're maybe never going to use that unless you become a scientist or an engineer or a mathematician. You're not going to necessarily use all of the stuff they're using. But that's also true when you study history. Unless you become a historian, that's not going to be of any use to you. Geography, all of these different subjects. Like, the thing that you're learning when you're at school is how to learn and how to think. And doing maths teaches you really great problem-solving skills. And as I say, there's different ways of approaching things. And if you learn to do maths in that way, when you come to any problem in your life, you will approach it as a puzzle and you'll go, right, how do we do this? And if you get stuck, you come back and try again. It's that process of being stuck that is really important in maths, because when you get stuck, that's when you really start thinking. That's when you have to really use your brain.
Yeah. Isn't it the restrictions on teachers which prevent them from exciting pupils in maths? Kind of. I think I see what you're getting at. The limited time is definitely a problem. You have a curriculum to get through, and you have a very limited time. It doesn't feel like it's limited time for the student, but for the teacher, when you plan everything, how the hell am I going to fit all this into this amount of time? And then there's always the problem of, okay, so I have everything planned out. The students are simply going to have to do this much homework during this period to fit everything in. Oh, crap, they had 7 tests in other subjects during that period. Oh, crap, back to the drawing board and plan everything out again. And that is always a problem.
Yeah, I think it is just a time thing almost. It's the quantity of stuff they've got to get through. And you could say, oh, maybe we should add into the curriculum some more of this cool, exciting stuff that'll give them a bit of a sense of where they're going with it. But then, no, we've already got enough stuff to teach them.
Exactly.
And teachers kind of are under a lot of pressure anyway, because it's quite a high stress job. But the fact that, I don't know if it's true in all the other subjects, but certainly in maths, there is so much stuff and they literally can't afford it. And then if they're ill, or if, any of the students are ill, or if there's a school trip or anything that takes time out, that just makes it even worse. And sorry, I have to apologise. I keep mispronouncing the word math. It's being discussed in the chat. I have this weird tick where I just pronounce it maths all the time. That is something I will tend to do. It's in English.
The correct pronunciation.
Yeah, it's the correct way of pronouncing it. Yeah, that's right. I don't know. We were discussing this the other day because someone misspelt. Someone had a flyer where they'd accidentally put mathematic instead of mathematics. And I was like, oh, sorry, that's just the American. I don't know. Yeah. There's some really nice discussion in the chat. People are saying that, trying to be logical and creative, and kind of someone who worked as a web developer and designer. That's a really nice job that's kind of at the fourth, like at the connection between those two things, that you need to be able to code and do kind of the computer side of things, but also to actually make things look good. My brother is a web designer, actually, and it really interests me that he's got this really technical mind that can do all this stuff, but he also produces these beautiful websites that look really nice. And it is something you can do, you can learn.
Yeah, I mean, I was saying earlier about the creative side of things. I think it's one of the things that is really important in science as well, is the creative side of it. And as we've sort of been chatting away, just to keep my hands busy, I pulled out I do a lot of cross stitch, and if I've got a sort of random scrap of material that's big enough, I often sort of whip it up into a bit of a bookmark. So that's what I've been doing here. And I know sort of from my technical background, the cross stitch works quite well, because it's it's a regular pattern of squares, and then you're just going through doing various bits and pieces to it. And
it's pixels.
Yeah, exactly. And I find that there's a lot of stuff that I can do that looks really amazing, but it's just looking at the bits of fabric, picking some random colours, and then just starting to do basically a geometric pattern.
Yeah.
And it works really well.
I've actually found there's a lot of mathematical kind of needlework, cross-stitch, knitting, sewing, like stuff like that. There's a load of people doing that, and it's really nice. There's a few kind of Ravelry groups of mathematical knitting. Ravelry is like a knitting website. And yeah, I've cross-stitched so much stuff. Cross-stitch QR codes is quite a nice one. I cross-stitched space-filling curve, which is quite good fun. Because it is just pixels, you can basically do anything. I saw someone did a bookmark once that was like the panel of tools from Photoshop, but all of the pixels involved in that as a bookmark, which was quite nice.
It's quite cool.
Yeah.
Another question from the chat room. When did you realize that you really liked maths?
I think it's partly what we were talking about, that maths at school is kind of quite functional, and I think it was when I got to what in this country are A levels, so the end of high school, kind of 16 to 18. It's when you start kind of looking at more advanced stuff, and it was, I didn't actually pick A level maths because I wanted to be a mathematician. I was actually looking at being a doctor, and I was told definitely do maths for that, and maths was one of my strong subjects, so I thought might as well. And doing that A level, kind of you start looking at things like calculus, matrices, getting onto things like proof, and doing all of the kind of really, really good math stuff. And that was, to me, that was like, hang on, this is actually, there's a lot more to this than you realise when you're actually doing it.
That's the part where you're actually coming into mathematics as opposed to counting.
Yeah, before that it's arithmetic.
Yeah, exactly. It was the same for me. That's when I started appreciating the subject.
Yeah, that was Oh, there was a question a bit ago in the chat that maybe we missed. Someone said, "Is Graham's number prime, and can you count to it?" I'm going to say I probably can't count to Graham's number because it would take me too long. I wouldn't live long enough to do that. So if anyone doesn't know, Graham's number is it's not a hugely interesting number. It's just the biggest number that we know of, basically. So there are infinitely many numbers, but Graham's number is a number that someone has identified that has a particular mathematical meaning, but it's the biggest number that we've identified that's got a purpose, and it's to do with a problem in I think it's technically graph theory, but it's to do with the number of different combinations of something that you need to solve a particular question, and it is just this immense number. Like, it's so big that if you wrote it in tiny print in a book, it wouldn't fit in a book. Like, it's millions or billions of digits long, and it is the biggest number that we have a particular use for. Like, there are bigger numbers. Graham's number plus 4 is bigger, but there's no reason you would ever use Graham's number plus 4 for anything. Yet we may find a use for Graham's number plus 4 at some point, but I think it's not I say a use for it. No one actually practically uses these kinds of numbers, but it is kind of an interesting number that's the biggest one that we know of.
And it's even difficult to explain how to write it.
I'm gonna
the usual notations. You can't really write it as something to the something's power of,
Yeah, it's
even
kind
that
of
isn't practical.
Yeah, so essentially there's this notation called up arrow notation, which has been invented for writing down big numbers. It's one of those things I would really love to be able to write down, but I have to get a blackboard in here. So if you have like a number times a number, that's one level, and if you have a number to the power of a number, that's the next level up, and these arrows kind of let you go further than that. So it extends that, and you put an arrow between the numbers, so you could have like 3 arrow 3, and that would mean a particular thing. And to write Graham's number, you need like arrows of arrows of arrows just to even write it down, and it's just so huge. But as someone has correctly pointed out in the chat, it does end in a 7. We know that.
Someone in chat has just asked whether or not there are more puzzles. Do you have any more puzzles for us?
Yeah, do you want some more puzzles?
I think it's puzzle time.
Did we get the answer to the last puzzle?
Oh, yeah, we've not done the answer to the last one, have we?
Oh, yeah.
No, we haven't.
So, 1 billion seconds, it comes out about 31.6-ish years, 32 years-ish. So, Michael Phelps is not yet 1 billion seconds old. I'm not yet 1 billion seconds old, which I'm pretty pleased about. And it's something I'm looking forward to. I might have a party for my billionth second. It'll be a very short party, just 1 second. But it's about that, and I think it's quite nice because 1 billion is one of those numbers you can't really get a handle on. But if you think about 1 billion seconds, like that's less than a human lifetime. So then maybe that gives you a sense of what 1 billion is. I don't know. So 2 billion seconds is like about 60, 63-ish. Yeah. I like that. Okay. I think we did get a couple of correct answers. People were saying about 32. I think that the thing that makes me a bit sad about this puzzle is there are now things on the internet that you can use to just work this out, and I recommend them strongly. In fact, so there's a website called Wolfram Alpha, which has been done by the guys at Wolfram, and it's a universal calculator, but they call it a knowledge engine. So it's a calculator that's hooked into a database of things. So you can type into it like population of France, and it'll know what that is roughly to a recent thing, and you can then sort of put in population of France divided by number of bread shops in France and work out various useful or otherwise facts. And if you put in 1 billion seconds, it will tell you exactly how long 1 billion seconds is, and give it in various other units as well that you might not even want. It gives you in years, but it also gives you it in like pico,
Planck times.
Planck times and things like that you maybe don't care about, but it's nice. And Wolfram Alpha is really useful for when you need to do things like that, because it can interpret typed in sentences, which is quite good, but it ruins the difficulty of puzzles. If you try and set a puzzle, people will just use that. So should I do another puzzle?
Yeah.
Yeah, go for
We'll
it.
throw one out there and see what people do with it.
Wolfram Alpha though.
Yeah, no Wolfram Alphaing. So there's a watermelon, which weighs 2 kilograms. I don't know if that's a realistic weight for a watermelon, but whatever. And it is 99% water. Okay, so it's 99% water, and we put it out in the sun, and the sun kind of dries out the watermelon a bit. And when you bring it back in, you find that it is, I don't know how, but you find that it is 98% water. And the question is, how much does the watermelon now weigh? So I'll give people a minute to think about that. So it's 2 kilograms, and it is 99% water. And after it's been heated in the sun, it is 98% water. And how much does it now weigh? Which is good. Okay. Oh, there's some good questions here. So someone's asked, what is your least favourite area of maths? That's quite a mean question, because I now have to be mean to an area of maths. I think there's a bit of so the area of maths that I studied, because I did a PhD, I did a little bit of research, and the area that I studied was topology, which is to do with shapes. It's to do with kind of how objects fit together in space, and how things connect up in higher dimensions and stuff like that, which is quite... I find it quite cool. There's a lot of diagrams. It's nice, and that's kind of part of pure maths, which is just this this whole branch of maths which is just kind of theoretical stuff. Things like algebra, geometry, topology fits in there, and kind of maths that is done for the sake of maths. Whereas opposed to pure maths, there is applied maths, which is where you're studying things like fluid dynamics or kind of more physicsy stuff, or financial maths, and kind of statistics maybe fits in there as well. And there's always this kind of not rivalry. There's a rivalry between pure maths and applied maths. So I was definitely on the pure side. So I'm not going to say there's anything wrong with applied maths, because it is the most useful maths. People are more willing to pay you to do applied maths than they are to pay you to do pure maths for some bizarre reason. Pure maths is finding out about the universe. It's answering these questions that no one's asked, whereas applied maths is actually answering these questions. And it's, that's kind of, I'm not going to say it's my least favourite area, but I'm definitely on the pure side out of the two, if that answers it without offending anyone.
Yeah, I tend to agree that I think the pure mathematics is more fun to do. But then I teach physics as well, so I have more use for the applied stuff there.
Yeah, well, it was interesting because when I did my PhD, I was looking at topology of physical systems. So I kind of had to learn a bit of physics in order to actually study them. So I was looking at like orbits, particles orbiting under gravity and things like that. And I didn't really know any of that side of stuff because I'd always just done the pure math stuff. So I had to learn kind of dynamics and Lagrangian and Hamiltonian stuff and the bits of physics and things to be able to kind of model these physical systems. But I wasn't actually doing any of the calculations. So I was just looking at kind of the shapes and the kind of the different symmetries of the systems that you get. So it was quite a nice way of looking at it. So I think technically somewhere on one of the forms it had me down as doing applied maths, but we made sure that it was definitely a pure maths PhD that I ended up with, because I was generally just doing pure maths. So
yeah, I had a physics professor that let's see if I can say what he said. He said something about like when you run into a math problem that you can't solve, you need to just give it to a mathematician, but make sure you remove all the physics first, because the mathematicians won't have a damn clue what to do otherwise.
Yeah, I think we're quite good at abstracting things. There's a lot of these jokes that you hear, there's a mathematician and a physicist and an engineer or whatever, these jokes, and in it the mathematician is the person who basically abstracts everything so far that they're not actually solving a real problem anymore. Right. And the engineer is the one who always does it in the kind of bodgiest possible way, and the physicist does something else. There's all these kind of stereotypes about it.
Spherical chickens in a vacuum.
Yeah, exactly, yeah. You abstract things too far and there's no friction and everything's a sphere, and it doesn't really actually help you solve a real problem. But yeah, as I say, there are applied mathematicians who are obviously a bit more up on these things, and yeah, I think the pure math side is definitely important and definitely useful, and a lot of the things that pure mathematicians have discovered have gone on to be used in other things, which is quite cool. And there was a friend of mine wrote a piece for Nature last year, a couple of years ago, about the unplanned impact of maths. And he basically found a load of case studies of things which mathematicians had worked out because it was there, and they just wanted to work it out and get this area of maths solidified and worked out. And then later on, someone went, oh, we need to work out how to do this, and grabbed this bit of pure maths and used it to actually solve a real world problem, which is nice.
Yeah.
Cool. Okay, so we've got some answers to the puzzle here. So we've got 1.9, 1.98, 1.96, 1.98. Someone says half a kilogram. So I think this is quite a nice little puzzle. It's kind of interesting, and it surprised me when I first heard the answer to this. Should I go with the answer now, or?
Sure.
Yeah, go for
We're
it.
all happy? So it's actually, I think maybe someone said this, but it actually turns out to be 1 kilogram. It loses half its weight. And kind of people, I think, are calculating what 99% is. But if you've got something which is 99% water, only 1% of it is kind of solid watermelon. So only, out of 2 kilograms, only 20 grams of it is actually solid melon. So when the water evaporates to the point where it's 98% water, that 20 grams of solid now constitutes 2% rather than 1%. So the whole weight of the thing is now half what it used to be. So it's quite a nice thing. So you end up with, it's lost literally half of its weight is 1 kilogram now.
That's, I think most people do what I did, start out with the mass equals, well, the mass of the water would be 2 kilograms times 99%.
Yeah.
And then you try to sort of work out, something is supposed to be X times 0.998, and it just...
Yeah.
Yeah.
Yeah, it's kind of... Yeah, it surprises you, yeah. Oh, wow, look at the time. That's flown by.
Oh, yeah.
Wow. So one final puzzle.
Yeah.
Should I do a final puzzle? Okay, so this is an international puzzle. I've got different answers for different countries. So it's to do with coins, which is why it's got slightly different answers depending on where you're from. So the kind of the background to this puzzle is, for instance, if you have a 20p coin, which you do in the UK, and you have 3 20p coins, you can't pay 50p exactly, right? That's the kind of the premise of this, is that if you've got 3 20p coins, you can't pay exactly 50p to someone if they're not going to give you any change, even though you've got more than 50p. So bearing that in mind, the question is, what is the largest amount of money you can have in change so that you can't pay a pound or any multiple of a pound exactly? And if you are in America, I've got an answer for the equivalent problem, that you can't pay exactly $1 or any multiple of a dollar using coins, and it's kind of the amount is more than a pound, it's more than a dollar, which surprises people slightly, but that's the puzzle anyway. So give people a couple of minutes to think about that.
Not being familiar with exactly what coins are available in either place,
in
That'd be a
the UK,
problem.
we've got coins that are in decimal, so pound is 100 pence, 50p, you have a 20p, a 10p, a 5p, 2p, and a 1p. Whereas in the States, as well as having similar things, they've got, I think it's the dime, which is 25 cents.
Yeah.
I don't know if they have the equivalent of a 50 pence.
Isn't that a quarter? A quarter of a
Yeah,
dollar would be a
quarter is
quarter,
25. A
Yeah.
dime is 10
a dime's
cents.
10 cents, yeah.
Nicholas, 5?
Something like that.
Yeah.
Yeah, in Sweden we don't have any of those. So
I think in euro, a euro coins are the same as pound coins.
we don't
same
have
answer.
euros either. So
In England, we have a £2 coin as well now.
Yes, we do. Someone on the chat says in Scotland we use sheep. No, I think it's just the same coins as in Britain, in England and Scotland. So yeah, I think this is quite a nice puzzle, because even if people are a bit kind of afraid of maths, they're still very happy to work out things to do with money. So people will have a go at this one. And in fact, one of the taxi drivers, I always get conversations with taxi drivers. One of them said, what do you do? I said, do maths. And he said, people often say that they're not very good at maths. He said, but if they're in my taxi and they're drunk and I give them the wrong change, they will definitely be able to tell me straight away. They will not allow me to shortchange them. Even if they're really, really drunk, they will still realise. So I think they're secretly better at maths than they say they are, which is nice. Okay, so it looks like Australia has similar coins. Do you have 1 and 2 cents in Australia? Someone's got them all there. But down to 5 cents. Okay, so the question is to not be able to make a pound or any multiple of a pound. So £2 coins wouldn't necessarily be of any use because they would allow you to make £2. Okay, so Australia don't have 1 and 2 cent coins, so it will be a slightly different answer for Australia, which I will attempt to calculate quietly while I'm talking.
So we've got 2 more minutes. Have we got any more last minute donations for people to put in? If we put in, we are going to be at the 3,100 mark, which would be a nice target to get to.
Yeah, speaking of coins, yeah, anyone got any spare ones? Yeah. Yeah, and the other reason I like this problem is because this actually came from a real world situation. Because in Edinburgh, when you get on a bus, they don't give you any change. So I had a friend who needed to pay £1 on a bus and couldn't actually pay exactly £1, and wondered to what extent could this be maximally annoying that you couldn't pay £1 but still have more than £1. Anyone got any answers?
I've not been giving it a go.
No, me neither.
Okay, so we've got a suggestion of £1 1p. So can I ask, how are you making up your £1 1p? Like which coins are you using to make that?
Boardspits has just put it up.
Okay,
His own version. So Board's got 50p, 2 20p's, a 5p, and 3 2p's.
Okay. So that works. But you can actually do more than that. You can do more than that totals. So that totals, what is it, 90... That's £1 1. But you can do more than that. Yeah, so Dave asks, why don't you use 3 20p's? Because if you've got a 50p, you can still have 3 20p's with that and not be able to make £1. And in fact, you can do more than that.
You have a £2 coin.
Well, you can't have a £2 coin because that lets you pay a multiple of £1.
Ah, fair enough.
So, yeah. So Dave says, or 4 20p's. So you can have a 50p and 4 20p's and still not be able to pay £1. So that's a hint. We've got another solution in there that says 3 2p's, 1 5p, 2 10s, 1 20, and 1 50, which is, I think, also £1 1. And it's good, but yeah, the fact that you've got 10p's in there means you can't have more than 2 20p's. So if you don't have any 10p's, you can actually get more 20p's in.
Okay, I think we're gonna have to wrap it up. So let's give the answer.
Okay. Yeah. Okay. So the total is, if you've got, it's similar to this. So you've got 50p, and you can have up to 4 20p's with it. You can have a 5p, and you can then actually, yes. So this one says, and then 3 2p's. You can actually have up to 4 2p's with it as well, because you still can't make 10p out of those. So the total is 143. And if you're in the USA, it's slightly different because you've got the quarter. So in the USA, the answer is $1.24.
Okay. I believe our time is up. So thanks a lot for joining us.
Thank you. Yeah.
Any last word from you, Womble?
Maths is fun.
Yeah, it is.
I think we've had fun with maths, yeah.
Yeah.
Thanks very much, everyone.
It's a subject that gets misaligned, I think, sometimes
Yeah.
by some people. Bless it, poor little maths.
Cool.